All right, so this problem is a lot like the last one. So we're going to call this 60B. Okay? We're going to call it 60B. Try to get an understanding of what's going on. So instead of going from 0 to 2 pi, we're going to go a little harder. We're going to go from 0 to 3 pi. Okay? We have to know what that means. That means we're going from 0 to, like you said, 360 plus 180, right? Mm-hmm. All right, so that's 360 plus 180, right?
340.
How much?
340.
No, 360 plus 180.
I don't know.
Isn't it 540?
Yeah.
Okay. That was close. You just forgot to carry the 2.
Yeah.
Okay? So we're going from 0 to 540 degrees. Okay? That means that we have this, and we're going around, right? From here to 360 and to here. Okay? So we're looking at this area twice and this area twice. Does that make sense? So if the angle we're looking for comes up in this area or this area, there's going to be 2 of those. Does that make sense? Okay? Alright. Probably not yet, but let's try to make sense of it. Alright, so let's solve this. Divide by 7, divide by 7. So we got cosine of theta equals 2/7. Right? So then I just take my calculator, right? And I say, well, cosine inverse of 2 divided by 7. And to make this easy, we're going to do it to the nearest degree. Okay? That way we don't deal with decimals. Fair enough? Okay? Equals 73.39. So actually 73. We're just going to call this cosine inverse of 2/7 equals 73 degrees. We're just going to deal with that. We're not going to deal with the decimals. Okay? Alright, so that means that our first angle that we are talking about is right here. Right? In fact, if we talk about 70, it's more like right here. Does that make sense? 73? Okay? So, we're talking about this triangle, right, that has a 73 degree angle on it, and its cosine, right, cosine is equal to adjacent over hypotenuse, right? And the hypotenuse, well, that's always positive. But in this case, the adjacent, right? This adjacent part, right? This is positive. So it's positive over positive. That's what we want, because it's positive over positive, right? But what could we also have? Let's think about that. So we have this. We could also have this one, and this one, right? Okay? Now, so those are all 73 degrees from here, right? Now, we could have a negative over a negative be a positive, right? But we already said that the hypotenuse is always positive. So if the hypotenuse is always positive, that means that the only ones we can look at are where the adjacent side is positive. That means this side we're not looking at. We're only looking at that side. Okay? Now, we said it would go around not just once, right? But 1.5 times. Which means that now we are looking at this first angle, which is 73 degrees. But also this second angle. How much is this guy? Since this is 73, how much is it to go around?
283 or 287.
So it's 360 minus 73. So we know that's a 7, right? Good. 287. Perfect. So 287 is the next angle. And then it's going to keep coming around to hit here again. Which means it's how much?
146.
Good. 360 degrees plus 73. Right? So it's going to be 3, looks like 3, and carry the 1. 433, is that right? No. Is that right?
Yeah.
Okay. 433? Is that what you said?
No. I just did 73, 73.
Oh. Okay. So remember, you got to add that 360 plus that. And that's why we've been asking you to be able to tell me what a degree is, what this angle is. Can you draw the angle? So does this make better sense on how to do this problem? So now if they give you any of these problems, you can deal with it. Right? Cool. I like it. If you were paying attention, you probably have a better idea